Hello students. So today discussion is about metals and non-metals chapter. Very important topic. First of all students, what are elements? Atoms of same type are called as element, and these elements are classified into mainly two categories. One set of elements are called as metals and other set of elements are called as non-metals. First of all, why do we need to classify? Students listen, classification anywhere helps us to understand easily in a very easy format. Understanding what? Understanding the physical properties and the chemical properties of the elements. On the basis of physical and chemical properties only, these elements are classified into mainly metals and non-metals. Of course, metalloids and noble gases are also there. Mainly metals and non-metals. So what are physical properties? Physical properties means like its physical state, melting boiling points, densities, solubilities, color, all these comes under physical properties, students. Then what are chemical properties? How this element is reacting with oxygen, how it is reacting with nitrogen, how it is reacting with acids, with bases, with water, all comes under chemical nature, chemical property. So this classification is mainly based on physical as well as chemical. So main classification, students, which are classified into metals and non-metals? Elements are classified into metals and non-metals. So to discuss about the concept, first of all we are going to cover classification of elements, occurrence of metals, physical properties of metals, chemical properties of metals and uses of metals in this video. So to start with, classification of elements, like I said, there are more than 115 elements known today. That means more than almost 118 elements were there. So out of 92 elements were naturally occurring elements and the remaining are artificially synthesized elements. That means majority are naturally occurring only, artificially synthesized radioactive elements few are there. On the basis of their general characteristics, they are broadly divided into four groups: metals, non-metals, metalloids and inert gases. Among the total elements discovered, approximately 80% of the elements are metals only. That means major portion of the periodic table is occupied by the metals only. What are these metals? So why we are calling them as metals? So what are the characteristics of metals? What are their physical, everything we'll discuss, students. So total how many types? Into four groups, four categories, mainly metals, non-metals, and also we have other set of elements called as metalloids and noble gases also. First of all, occurrence of metals. So where can we find these metals? What are metals, students? Iron, gold, so all these are metals only, right, students? Metals are found in these two states. One is free state, second one is combined states also. Free state means, listen carefully, free state means chemically uncombined state. A metal directly exists as that, an element directly exists as that element, pure form. Uncombined state is called as, students, free state. Can you guess the answer? Which metals exist in the nature in the pure form? So mostly, students, the metal gold, platinum exist in the nature in their pure forms, unreactive. They are not unreactive, not completely, we can't say that. They are least reactive. They are least reactive. So only some metals like gold, silver, platinum, least reactive metals. That doesn't mean they are unreactive. They are reactive, students, but they are least reactive. Etc. are found in the free state, that is uncombined state. Most of the metals are found in the combined states as oxides, sulfides, carbonates, silicates, phosphates, nitrates, nitrites, all these combined states only. Majority of them are available in the nature in their oxide form. What is oxide? O-2 is oxide. Sir, non-metal oxidation. So these metals combines with non-metal oxide and it exists in the nature in their mainly oxides. Of course, carbonates also, of course, phosphates also, sulfates, nitrates also. Let us take a few examples, students. First of all, let's combined state. Reactive metals like iron, aluminium, calcium, magnesium, etc. generally occur in the form of their compounds such as oxides, the same carbonates, nitrates, chlorides. Example, FeS, iron sulfide, Al2O3, aluminium oxide, CaCO3, calcium carbonate. For example, students, iron. We are using iron for many purposes. Yes or no, students? For iron bench, for doors, for construction, for materials, many things, for articles, many things, many places we use iron, bridges, all construction purpose. So where do we get the iron? Like how it is available in the nature? Do you think iron directly available in the nature as iron? No. Iron available in the nature in combination mainly with its oxides or sulfides only. Understood? So how can we get the metals? First of all, we should extract that. Where it is present? In the soil only. Yes or no? In the rocks. So we should extract that. That is called as mining. Yes or no? They dig big holes. Yes or no, students? In the mining. So they collect all the soil nearby where there is a more concentration of iron. Then they will purify it. They will refine it ultimately. That whole discussion comes under a chapter called as metallurgy. Okay, so then they can some physical process involved, some chemical process involved in order to separate that iron oxygen or iron sulfur. Ultimately they will purify, they will synthesize pure iron, they will produce pure iron. If pure iron is there in the nature, in general in the nature? No, in the combined form only, but we can separate by physical methods as well as by adopting the chemical methods also. Got the clarity? Aluminium is also used in many cases, like car wheels, car bodies, everything, lightest metal, students. So how aluminium is available in the nature? Bauxite ore, Al2O3, aluminium oxide. Copper is mainly used for electric transmission wires. No, copper bodies also nowadays. So where can we get the copper? Pure copper is there? No, copper oxide or copper sulfide. So, but gold, how gold available in the nature? Gold available in the nature as pure gold only. Yes or no? Have you seen the videos in the YouTube, students, collecting gold nuggets, gold pellets, simply by washing the nearby rivers in some countries where there are more gold mines, mostly in the Africa. So that's how gold available in the nature as gold only. That's not completely unreactive, it is reactive, but in general in the nature it is available as pure form, that is called as free state. But majority of the metals are available in the combined form only. Combining with what? Combining with oxygen called as oxide. If it combines with chlorine called as chlorides. If it is combining with CO3 minus 2 radical called as carbonate, phosphate, nitrate, it depends, right? So that's all the occurrence. Physical properties of metals. So like I said, what are physical properties? Physical states, melting points, boiling points, densities, solubilities, color, taste, odor, all comes under physical properties. So metals are solids. In general, students, all the metals are solids. Exceptions are there except mercury, hydrogyrum. Yes or no? Mercury is the metal which is liquid state at room temperature, but remaining all the metals are solids only. Metals are hard. Exceptions, sodium, potassium. Metals are very hard solid, students, but there are exceptions which are coming from the first group elements, like sodium, potassium. They are soft metals, like we can even cut the metal with a knife also, so they are soft. So metals have metallic luster, that means metals are always shiny in nature. That is the characteristic property of metal. Metals have a shiny nature. Shiny nature means, students, for example, gold, best example, gold is shiny. Yes or no? Gold has a unique color, that's why we are using that as an ornamental purposes, right? Look at silver. Silver also has a unique shine, right? Silverish. Look at copper. Students, do you know in how many colors all these metals are available? Just guess your answer. The question is, in how many colors all these metals are available in the nature? All these metals are available in the nature, mainly 3 colors only, students. One is gold, only gold available in the gold color, right? Next, copper, only copper available in the copper color, like shiny brown, light brownish kind of. Next, third one is remaining all the metals are available in silver color only. For example, silver is silver anyway. Cut iron. What is the inside part? Silver. Look at aluminium, silver color only. But of course, there is a change in the gradation of the silver. Okay, some are more whitish, some are more grayish, but ultimately silver color only. So but not just the color, they are shiny in nature. Understood? That nature is called as lustrous nature. Next, metals have high melting points and boiling points. Correct. Why? Because, students, metals are very hard solids. The reason for having high melting and boiling points, first of all, what are melting and boiling points? The temperature at which a solid changes into liquid is called as melting point, and the temperature at which a liquid changes into vapor is called as boiling point. These metals have high melting and boiling points because of the metallic bonding. That means all these metal atoms, they exist in the nature, like in that state, by having the force of attractions between each metal atom. So they are called as kernels, which are guided by the free electrons, and they develop the strong forces of attractions. and to break these attractions, it's not so easy. We need to provide more temperature. So obviously providing more temperature means what? More is the boiling point, more is the melting point. That's why in general metals are hard solid. So next, metals are malleable in nature. Malleable means can be made into very thin sheets. That is malleability property. For example, students, your school bus, right? Like how it is made? Like look at the school bus. It is completely having this shape. Yes or no? Completely, it has a one body. What it is made up of? Iron mostly. How it is made into that shape? Because of this property called as malleability, students. So what is malleability? Making a metal into very thin sheet, that is called as malleability. Can we make oxygen into thin sheet? No. Can we make nitrogen? Can we make carbon into thin sheet? No. Metals are malleable. By constant beating, we can make a metal into very thin sheet. Iron sheets are there, right, students? Best example is even silver foils, which are decorated on the sweets, as well as aluminum sheets, which are food storing. So these are all the examples of malleability. Metals are malleable. What is malleability? Making a metal into a thin sheet. So right, metals are ductile, can be made into thin wires also. That nature is called as ductility, students. For example, electric transmission wire. Yes or no? Even iron wires also there. We used to hang clothes sometimes, right? So what that nature is called as ductility. Make a metal into thin wire. Can we make a carbon into wire? No. Of course, there are nowadays we have some students, new discoveries are there from carbon only. So carbon fibers are there, where they can be malleable also. So that's a recent developments. But in general, elemental carbon, the answer is no. They are non-malleable, non-ductile. So next, metals are good conductors of heat and electricity. This point is very, very, very important. Metals are good conductors of heat and electricity. What is the reason why they are good conductors of heat and electricity? The reason is metals contain some free electrons, students. Metals contains free electrons. Free electrons means metals contains valence electrons, either 1, 2 or 3, yes or no? And metals always show tendency to lose electrons, yes or no? So these electrons which are present in the metallic solid behave like a carriers of this electricity. They are freely moving electrons. So those electrons are the reason for the conduction of heat and electricity. But non-metals, do they have these free electrons? No. Non-metals show tendency to gain electrons. That's why they cannot easily release those free electrons. Understood? So metals are good conductors of heat and electricity because of free electrons. What are free electrons? The electrons present in the valence shell, and the metal should easily lose those electrons. Those electrons are called as free electrons. Next, metals are sonorous in nature. Produces sound. Not exactly. Produces sound means if you hit on the table also it gives a sound. Does it mean it is sonorous? No. Produces a ringing sound. That is sonorous nature. Ringing sound means your school bell. Ting, there was some vibratory motion. Yes, student. That nature is called as sonorous in nature. What is? Next time don't say only produces sound. Produces ringing sound is sonorous. Got the clarity? These are the physical properties of metals. Next, we are entering into the chemical properties of metals, students. First of all, mainly we have reaction with oxygen, acids, as well as water. First, reaction with oxygen. Any metal, if it react with oxygen, it forms in general metallic oxide. That's it. Metal plus oxygen gives rise to metallic oxide. Here, look at the reactions here. Magnesium plus oxygen gives rise to magnesium oxide. Sodium plus oxygen, sodium oxide. Calcium plus oxygen, calcium oxide. Iron plus iron oxide. Understood? Got the clarity? So metals in general, when they react with oxygen, they form the respective oxide, and the ratio of the combination depends upon the valency of the metal. Here magnesium valency is 2, oxygen valency is 2, they combine in 1:1 ratio. In the case of sodium valency is 1, oxygen valency is 2, so they combine in 2:1 ratio, Na2O. Understood? Got the clarity? So now, what is the point to be discussed here is, these metallic oxides, they are basic in nature. They have basic properties, and these metallic oxides, when you add it to the water, they form the respective hydroxide, students. Hydroxides are direct bases, arrhenius bases. They can release OH minus ions or not. Metallic oxides are basic in nature. When you add into the water of these oxides, they form the respective metallic hydroxides, which are arrhenius bases. So this is the point you have to remember. Oxides are basic in nature. Oxides in water, they form hydroxides, which are mostly arrhenius bases, right? So that's the reaction with oxygen, with metals, with water. Students, have you seen the reaction of sodium into water? The most famous reaction. So metals are highly reactive with water, students, but not all the metals. Not all the metals. Some metals are very vigorously reactive. Some metals are moderately reactive. Some metals are least reactive. For example, drop sodium into water. What will happen? A sudden explosion takes place. So, students, why sodium is highly reactive with water? Drop iron in water. Anything happens? Nothing happens at the moment, but over a month, 2 months, in a year, rust will form. Yes or no? That means slowly it is reacting, right? Drop gold in water. Is anything happens? No. Gold is unreactive with water. So it depends upon the type of metal, students, but in general, when metals react with water, they form the respective hydroxides and they release a gas. That gas is called as hydrogen gas. That is what you have to remember in this reaction. So metals react with water to form metallic hydroxides and they release hydrogen gas. You already know the nature of metallic hydroxides. What is their nature? Direct bases. So, and these, for example, magnesium plus H2O, what does it form? Magnesium hydroxide plus H2. Do all metals in water form hydroxides? Means no. No. Moderately reactive metals in water, they do not form hydroxides, they form oxides. For example, iron, it doesn't form hydroxide, it forms oxide only. Got the clarity, students? So, like chromium, like lead. So, mostly they form oxide, they do not form hydroxide. Then which metals form hydroxide? Highly reactive, like sodium, potassium, magnesium, calcium. These metals in general, they form hydroxides and they release hydrogen gas. Is common for all the metals. And gold, it is unreactive in water. Gold is, and platinum also, students. So that's the reaction with water. Next, reaction with acids. What are acids? Acids are the compounds which can release H plus ions. Yes or no? When these metals, when they react with acids, they liberate hydrogen gas and they form the respective salt. Look at the reaction here. Zn plus 2HCl, zinc plus hydrochloric acid. What do we get? Zinc chloride, ZnCl2 plus H2 hydrogen gas. Yes or no? If it is a magnesium, we'll get MgCl2. If it is a sodium, we'll get NaCl. It depends. The salt depends upon the type of metal and the type of acid. But ultimately, what is the common thing? Hydrogen gas will be released. Hydrogen gas is released when metals react with water as well as with acids also. This reaction comes under displacement reaction. Understood, students? Metals react with acids to form metallic salts as well as hydrogen gas. This is a reaction. Simply zinc is more reactive than hydrogen. So it displaces hydrogen from HCl and it forms ZnCl2 plus H2. Next, metals replace metals. Sometimes, not every time hydrogen also. Metals can replace the metals also. Then which? I already have said the one point. In all these metals, some metals are highly reactive, some metals are moderately reactive, some metals are least reactive. Now, which metal replaces which metal? Highly reactive metal displaces less reactive metal from its solution. Yes or no? That is called as metals replaces metal or displacement reactions. A more reactive metal replaces a less reactive metal from its salt solution. Magnesium replaces copper from the copper sulfate solution to form magnesium sulfate and copper. Look at here, this is a magnesium, students, magnesium. This is a highly reactive metal and this is copper, less reactive metal. Then what will happen? This magnesium takes the position of copper and the copper will be released. Yes or no? Copper will be free from the compound. Why? Why? Because magnesium is more reactive, sir. Why magnesium is more reactive? If that is your doubt, it depends upon electronic configuration. It depends upon atomic size. All these factors influences the reactivity. And in the coming slide, I will show you the reactivity order also. Magnesium more reactive than copper. Opposite reaction happens, students? No. In the opposite reaction, copper is least reactive. Can it displace magnesium? No. Understood? Magnesium is more reactive. That is why it is displacing copper from the copper sulfate solution, right? Next, activity series, the same, like the arrangement of these metals in the decreasing order of their reactivity is called as metal activity series. Decreasing order means from high to low. Look at what's the first one? Potassium, sodium, magnesium, aluminum, zinc, iron, lead, mercury is there, copper, silver, gold, platinum. So platinum is the least reactive. It is not given. Gold is the least reactive in this series. So potassium is a highly reactive. But there are, in the beginning slide we have seen that there are like almost more than 90 elements or metals. Then why all these metals are not included? The reason is, students, whatever the metals which are included in the metal activity series, they are most frequent. These metals are most frequent. That's it. That's why they are given in this metal activity series. Most frequent in the sense, most of the chemical compounds, most of the reactions, most of the combinations we can see from these elements only. That's why only these elements were added in the metal activity series. Sir, why not scandium? Why not titanium? Why not any other element? Means most, not most frequent. That's it. Got the clarity? And in this activity series, hydrogen is also included. Of course, it's not given here. In the metal activity series, hydrogen element also there, students. Why? Because hydrogen has also metallic property. It's a non-metal, but it also shows metallic property. Why? Because hydrogen can also lose electrons. Understood? Got the clarity? That's the reason. So based on this metal activity series only, you have to identify which is more reactive, which is less reactive. For what reason? For the displacement reactions. Highly reactive metal displaces less reactive metal. Next, noble metals. Like I said, some metals are least reactive. They are called as noble metals. Gold, silver, platinum. No, metals like gold, silver, platinum, etc. retain their luster because they do not react with air, water or acid. So they are called as noble metals. For example, students, gold. For over long time also, the shiny nature decreases very less. Yes or no? It becomes dull. Over years of time it will take. In general, it doesn't happen in the normal conditions. But iron, what happens to iron? Is it still the same silvery? No, it will become black, brownish color. Rust will form. Yes or no? Copper, does it have the same? No, it will become greenish compound. That is tarnishing, right? It contains copper carbonates, copper hydroxides, right, students? So like majority, aluminum also forms aluminum oxide, zinc forms zinc oxides. So all these metals, they react with oxygen and they form a layer on the surface. But these gold, silver, platinum, mainly gold and platinum, they remain as it is. Why? Because they are least reactive. Silver also least reactive, but silver react with sulfur, students. So that forms silver sulfide. That is called as tarnishing of silver. It will become black at the edges. Yes or no? That's the reason. But in general, all these three elements, they are called as noble metals. Gold dissolves in aqua regia. Aqua regia is a mixture of concentrated nitric acid. What is the formula of nitric acid, friends? HNO3, nitric acid, and concentrated hydrochloric acid. What is the formula? HCl. In the ratio of 1:3. These can dissolve gold, mainly used for purification of gold or giving shine to the old gold. For that purpose, this mixture is used. Mixture of nitric acid and hydrochloric acid. Pure gold is 24 karat gold. Have you heard about 24 karat gold, 22 karat gold? It is very soft and cannot be used for making ornaments. It is mixed with some silver or copper to make it hard. The reason for 24 karat, 22 karat gold is, students, 24 karat gold, it's not very soft like here. It is said it is having some brittle nature. Gold is having, it is soft, it is brittle nature. So because of this brittle nature, can we make ornaments out of it? No. Why? Because they are still brittle, easily breakable. Brittle means easily breakable. So to make it hard, they will take 22 parts of gold and 2 parts of either copper or silver. That is called as 22 karat gold. Understood? What's the meaning of 22 karat? 22 parts of gold and other 2 parts of either silver or copper. That is called as 22 karat gold. If it is not, nothing is mixed, only 24, that is 24 karat gold. Mainly it is used to make gold bars. Pure gold, only like rock solid gold, pure gold. So mainly ornamental purpose also there. Sometimes you can find 24 karat gold. Still it contains some mixtures. Otherwise, if you want to make a gold with pure gold ornament with 24 karat gold, it is not strong. It will be brittle in nature for sure. Got the clarity why 22 karat gold, students? Right. Next. So uses of metals like iron. What is the use of iron? Where do we use iron? Like we said, discussed in the previous slides, iron is mainly used for building, construction purposes. Yes or no? Used for making pins, nails, nuts, bolts, tools, machines, construction, buildings, bridges, everywhere. The most used metal is iron in the infrastructure. Got the clarity? Aluminium, it is used for making utensils, wires, furniture, parts of aircrafts, vehicles, machines for packing food and medicines. Also, medicines means, have you seen the backside medicines? Foil is there, na? Silvery. That is aluminium. and food packaging also aluminum foils only, and machines, vehicles, car bodies. Why? Because it is the lightest metal, so that's why mainly aluminum is used in all these cases. Next, copper, used for making wires, vessels, electric gadgets also. Good conductor of electricity. Electric transmission wires are mostly made up of copper. Next, gold, it is used for making jewelry, coins and metals. This is a common, we already know. Silver also have the same use, making jewelry, coins, metals, etc. Platinum, it is used for making jewelry, electric gadgets and plugs in vehicles, etc. It is also one of the good conductor of electricity. In electric transmission also platinum is used. Sodium, it's a compounds are common salt, chemical sector, etc. Mostly sodium, pure sodium, instead of pure sodium, sodium is used to make other chemicals like sodium chloride, like sodium hydroxide, like sodium carbonate, washing soda, sodium bicarbonate. There are many chemicals which are coming from sodium, which are used in the normal reactions as well as in the organic reactions also. In organic synthesis reaction also, sodium is one of the key element to be used, students. Next, calcium, its compounds are used for making cements, glass, mainly calcium carbonate, calcium chloride, bleaching powder. What is the formula? Calcium oxychloride. Yes or no? So these are calcium ions are for used even for the potable drinking water, also good for plants and all the living things also. And these compounds are also used for making cement industry as well as for making glass also. These carbonates of calcium and sodium are used. So mainly these are main elements. Like there are again 92 elements are there, but no, these are main elements which are we use in our day-to-day life. That's it about metal, students. What we discussed in this video: occurrence, physical properties, chemical reactions, uses, metal activity series. Yes or no? These classification is very, very important. You have to follow. And the pending one is non-metals, that we'll discuss in the next video. Thank you, students.